University of Illinois Extension.
All right. So my name is Emily Swihart. I am the horticulture educator in Rock Island, Henry, Mercer, and Stark counties. I am very excited to be with you all talking about one of my favorite subjects, planting for pollinators. So tonight I'm going to dive in. If you have questions, please go ahead and put them in the chat throughout the night. We'll save time at the end for some questions. And I think I'm okay with you all unmuting yourself at the end of the presentation, and we can just engage in that format since we are using the wonderful world of technology. So tonight we're going to be talking about planting for pollinators, and what we're going to be doing is looking at one particular study that I think demonstrates a really unique relationship that native plants have along with plant cultivars, and how we can use these results possibly to make decisions in the future regarding our landscape, and maybe not. We'll get into that. So here we go. Maybe there. So before we begin and talking about specific plants, I want to step back and look at the prairie ecosystem as a whole. So it's in the Midwest. Let's go back in time. Let's just time travel just a little bit out of this modern era where we can all be joining each other, together from afar. But let's go back, say, like the early 1500s. So during this time period, this is when we were just starting, European settlers were just starting to discover, and I use that term loosely, the Americas. Just a couple of decades earlier, around 1500, Christopher Columbus found or discovered or landed in what we currently know as the Bahamas. So North America, Illinois, where we're at right now, was not settled, was not discovered, was not inhabited by European settlers. However, there were people here, right? We all know that there were First Nations people living and trading and moving and cultivating the landscape in the Midwest, in Illinois, probably in our backyards. So that is the ecosystem, that is the heritage of the plants that we are going to be talking about today. These are the native plants. These are the ones that were here so many more decades, centuries before European settlers ever came and modified the land in such massive ways. Now, mind you, First Nations people were managing this landscape. They were using fire, they were using grazing animals, they were in some cases cultivating the land. So it just looked so much different than how we manage the land today. I think it's important for us to understand that was happening and acknowledge that was happening. So with that context, keep in mind that these plants were also evolving with the native animals, bacteria, fungi that were here as well. And so what they would do over centuries of time, they developed adaptive strategies. Plants and animals developed adaptive strategies together. And so in many cases, they evolved these co-relationships, these mutually beneficial relationships. We are very aware, and by the title of my slides tonight, we're very familiar with the relationship between pollinators and flowering plants. And so we'll talk more about that. But I assure you there's many ways that plants and animals and bacteria and fungi, microorganisms evolved together. Illinois had a variety of ecosystems: tall grass prairie, woodlands, riparian areas. These had edges that intersected with each other. You can see it in the photo that we have here. It was a really dynamic landscape. That was pre-Illinois. So worldwide, let's just look at let's look at plants and animals briefly, just so we're all coming from the same location of information. So worldwide, animals pollinate about 75% of all the plant species that exist, and about 90% of the flowering plants. So we know that that it takes a pollinated flower to produce a fruit. We depend on so many of those fruits for our enjoyment, human diet, for variety in our meals. to rear other animals that we then consume. I'm thinking of things like alfalfa. So this relationship is one that directly affects the quality of our lives, our enjoyment. Oops, excuse me. Going too much. And so to understand this a little bit better, so that we can then make decisions on the actions that we take in our landscape, early flowering plants did produce pollen, and they were, but they did not produce that nectar, that sweet nectar that attracted most of the pollinators. Some of our pollinators, some of our native pollinators that we still have today, do utilize pollen, and we'll get to that. But through this evolution, this coevolution, nectar was a strong attractant. So pollinators or insects were attracted to flowers to obtain this very sweet, sugary, high nutrient, high carbohydrate, dense food source. And then pollen, either intentionally or inadvertently, got transferred from flower to flower because the insects were moving from flower to flower. And so they started co-evolving and they were supporting each other. Nowadays, there's somewhere in the neighborhood of 300,000 to 500,000 species of flowering plants. That's about 9 out of 10 of the plants on Earth. And so the efficiency of insect pollination has just proven to be a mainstay. It is an important, it is a wildly important aspect of a healthy ecosystem, maintaining a healthy ecosystem. And it is one that we should be concerning ourselves with, and we'll get to that because I think we all are concerning ourselves with it. The other form of pollination is wind pollination, and that is less intentional pollen. Insects move pollen from one flower that they like to another flower that they like, and so evolution can happen with a more intentional, with a more kind of strategic way. Wind pollination is kind of luck of the wind. So because we're going to be talking about pollinators, let's kind of understand the different social structures of them, because this affects how they move pollen and how they interact with the plant species that are available. So first up, we're going to be talking about bees right here. And then in the next slide, we'll talk a little bit about bees, and then we'll talk about butterflies and moths too. So the social structure of pollinators, there are solitary species, and these live by themselves. One female is responsible for providing for all of their young. So this, if the female does not succeed, the brood does not succeed in this scenario. So this is a pretty high stakes situation for a species. What this means then is that the female is requiring or expending more energy and is needing to access plants that provide and supplement high energy with low output, right? So she can't afford to be spending so much energy, so much time seeking out so many maybe different plants that are farther away. She just can't do that because she has to survive. She has to conserve her energy and make sure that she is then able to provide for her brood. So they target flowers that offer these high rewards. And it has to do, I think of this as a strategy of like work harder, not smart, or work smarter, not harder, because you have to be really strategic and really conscious of your energy expenditure. Then there's communal insects. So they divide and conquer the workload. The non-native species that many of us probably are familiar with, the honeybee, are communal insects. And they are so strongly communal that we can cultivate them in hives, right? They develop a social structure, they have different roles within the hive, and perform different jobs and tasks. And this then allows them to divide the labor, and then they can expend more, they can be higher productive with less energy expended. So one goes and finds a really fruitful patch of flowers, it will communicate that to the rest of the hive, and then they can all go there. So it is a sharing of information. They have the ability to go out and find things perhaps farther away, because then once one does, the rest of the hive can benefit from that one bee's discovery. And then there's the colony. So this is similar to communal structures, but a little bit different. And so colony forming species like the bumblebee, they will raise multiple generations and they'll have multiple families living, coexisting together, but they do not care for each other's young. So like I said, this is a kind of an in-between, but because they do live together, they still communicate with each other. They will share information and share the location of high resource plants. And so that can be effective for helping a colony survive and broods to be raised, as well as helping to be more effective at pollination. All right, so foraging and efficiency patterns. So bees, let's talk about them just a little bit more because they are the primary pollinator in Illinois. So they do collect pollen and nectar. Not all pollinators intentionally collect both of these, but they are seeking both. They will collect pollen with chewing mouthparts called mandibles. They will collect nectar using a proboscis, or their tongue. And now their tongue is a certain length, and it has a little spoon on the end of it. And so what they do is they are matching the flower corolla depth to the depth or the length of their tongue. Because if they can't reach the nectar, which is usually down in the lower parts of the flower, then it is not worth the bee to visit that flower seeking nectar because they can't reach it. It's mismatched. And so that is one requirement for bees to visit flowers, is that they have to be able to capture those nectar rewards with the length of their tongue. And then sight attracts them. Sight is a very strong, useful tool in the animal world, but we need to understand a little bit more about how it is used. Because if you can't find a flower, you cannot visit a flower. And if you cannot visit a flower, if the plant is dependent on insect pollination or animal pollination, then that species does not exist for very long. So bees see ultraviolet light and they do not see red wavelengths. So a couple of things. What this means, first of all, with the ultraviolet light, we do not see ultraviolet light, but bees do. So what that could look like to a bee, or so let's take like a yellow flower, like marsh marigold. To us, it looks like just this very standard, very monochromatic yellow bloom. But what bees see is two tones, because there's ultraviolet light that makes it visible. Their ability to see ultraviolet light makes it look two-toned. And I think of it kind of like as a runway or a target. Bees see it, and it's kind of like leading them right to the nectar and pollen, kind of saying like, here it is, right here, come on in. So that, I'm telling you all this to keep this in mind as we go through and talk about when we start modifying blooms and we start modifying colors. There's more that we need to be doing to understand what changes. I'm kind of giving away, I'm kind of like, this is a spoiler alert, but I want you to keep this in the back of your mind, because we're going to be talking about how breeding programs or how plant selection choices might be changing this, or might have an effect on how bees actually see the plants. And then also they don't see red wavelengths. So red flowers do not appear to them. And so they will not visit them because they're just not shouting out to bees as a resource. Butterflies and moths. So they collect nectar. That is primarily what they are seeking. They are not intentionally gathering pollen. This is an inadvertent transfer of pollen. So when a moth or butterfly is attracted to a flower to feed, they are in there trying to collect the nectar, and the sticky grains of pollen attach themselves voluntarily to the insects, and then they get moved once the butterfly or the moth goes to another plant. The butterfly is potentially totally unaware of this happening, but this is an evolutionary strategy it has occurred, and it does happen. And so what we want to be thinking about when we are planting to attract butterflies and moths is that they often need a place to land on. So they're going to be favoring open-faced flowers, somewhere where they can grab hold and feed, and they will not hover next to a flower. Now here, butterflies are attracted to bright red and purple flowers. And so if you are planting for butterflies, or the plant is specializing or has a specialized relationship with butterflies, then it is likely going to have or need to have red or purple flowers to attract those pollinators. Moths are oftentimes nocturnal. And so what this means is that they will be attracted to white or cream colored flowers because they are more able to see them in the darkness of the night, under the moonlight, and or fragrant flowers. And so if you are wanting to help moth populations or plant a moon garden, you would oftentimes have white or cream colored flowers, and they would have a fragrance to them. So we're going to move kind of into the study and why this is, why the study even existed to begin with, and then why I think it's really important for us to be aware of and start analyzing the results of it because of the pollinator movement. So about 20 years ago, well, in the mid 20th century, we had some authors who were way ahead of their time, starting to talk about the need for ecosystem conservation and some of the challenges that we now understand at such a broad level. But it really hit with the public kind of in the early 2000s, and it has grown ever since. And so the awareness of the critical function that pollinators play in our ecosystems is now universally recognized, and it's affecting the horticulture industry. It is affecting the plants that are available. So we have people buying books and watching movies. We have Pollinator Week is celebrated every June, and our plants are starting to have tags on them that say pollinator friendly or native. And so there's a strong desire, we're all seeing it, there's a strong desire to plant for pollinators, to help be part of the solution. So what does this mean? Well, it means that some of our landscapes are transforming. Some of the plant species that we're planting or incorporating into our landscape are different than perhaps they were 20, 30 years ago. Ordinances could be changing. It's a new frontier, and we are all trying to do our very, very best. With that said, we still like what we like. We like certain colors, we like certain forms, we like plants that behave well, that are going to be a certain size, that are going to maybe not seed so readily, they're going to stay in place. So there's an aesthetic, there's a human desire to have a landscape, or perhaps there's a legal reason to have a landscape that is according to a certain aesthetic that society has deemed to be desirable, or we have deemed to be desirable. And then there's the way these native plants, who evolved free of a lot of human input, how they behave, how they are naturally have naturally evolved to behave. And so this there can be some, well, this has inspired a whole breeding program, right? This has inspired so much research and so much plant development, that this is kind of where we're at nowadays. And so genetics and plant breeding, horticulture is the art and science of plants, and breeding and genetics and cultivation is art and science of improving plants. And you'll see I have that in quotes, because what does that mean? Why do we think that plants even need to be improved? This is a philosophical question. Perhaps they don't need to be improved, yet we manipulate them anyways. So the reasons that we try to manipulate plants, or we work very hard to manipulate plants, are for things like an improved food production. The corn that we grow in the fields nowadays is not what it was originally. It is so much more productive in terms of a grain output, and how, what that grain even looks like or tastes like. So that would be an example. Apples is another one. There's so much cultivation and hybridization, in apples, because we want you name your favorite cultivar, to be reliably flavorful, produced, whatnot. So food, we would improve it for feed. Kind of goes back to that corn example, having things more drought tolerant, having it more wind resistant. We would do for fiber, Cotton has come a long ways. Hemp has come a long ways, and it continues to come a long ways because we are needing more or wanting, different qualities. And so plant breeding programs can produce that oftentimes. Fuel for shelter, for landscapes, like the list goes on and on. So I hope you're getting the idea of, like, there's so many reasons why we as people are manipulating plants, or we are doing, whether it's in the lab or we are just selecting for, things that we like out in the field, out in the garden. You select out certain beets because they're growing faster than other beets. Perhaps when you're thinning a row, that's a selection activity that we're all engaging in. Nothing wrong with it, just need to acknowledge that. And we need to understand that that's where we're starting from in this conversation. So before we get into the research that I found quite fascinating, a quick definition of native and native cultivars, because this is what we're going to be comparing. So native, these are the plants that developed over time in a specific region or ecosystem. There's a lot of debate that can be had as to what size that ecosystem is or ecolocation. But basically, these are plants that have so much genetic diversity within the same species because they are oftentimes unmanipulated by people. And then there's native cultivars. These are variations of a native species. There can still be some genetic diversity retained. We'll talk about how some of the selections are made, but they are chosen for certain plant characteristics deemed worthy of selecting for or deemed important by people. And then we get involved in reproducing those cultivars. They are scientifically, they're still related, they're the same species, but they will have been selected, and human involvement will have taken place. So I hope that is clear. All right. Oh, there we go. So pollinator preference is what we're looking at. We want to understand when we have a straight species, a native species, and compare it to the same species, but of a cultivar, a popular cultivar, or a new cultivar on the market that is available to us all to plant in our gardens. What does that mean for the pollinators? Like, do they have a preference? Does the changes that we're making to the plant affect how appealing that plant is for pollinators? Because if our goal in our landscape is to plant for pollinators and aesthetically, for a certain style that we like, or with certain criteria that we deem important, that might be a variant or may not be reliably reproduced in a straight species, can those two goals coexist in our landscape? Let's find out. So the research on this is limited. This is kind of a new question that has been asked, and I feel very strongly, and there are signs of it happening, that there's going to be so much more information that comes out regarding this. It is inconclusive. This particular study that we're looking at was part of a master's project, and it has not been replicated. I think it could be. It just has not been. I still think it's worth exploring the research that comes out of it. So what the researcher was asking was the frequency of visits to the flowers at the family level, so the taxa, and then comparing native to non-native plant species. I've already covered that. So, so what is the attractiveness of a flowering perennial for pollinators? It's a question we're going to be answering. All right, the background information on the research. So Annie White is the author. She was the researcher and author of the paper. It was done in 2012. What she did is she compared 11 species, 18 plants of each species, and there were two different sites, site A and site B, separate from each other. The planting pattern was a randomized complete block design. This is a pretty standard planting plan for plant trials. They're rectangular shapes, kind of in a grid pattern. But they're randomized. It's not, they're all planted in alphabetical order. They're not planted, this species next to this species. It's randomized. And then she had a certain number of plant selections. So it was one selection or cultivar per species. And she used the visual observation method, excuse me, where she would just look and identify that she was not capturing insects. She was not taking them, under a microscope to analyze. It was just simply no animals were hurt in the process of this research type of observation. So it was her sitting out in the landscape at certain periods of the day for certain amounts of time at both sites and recording what she saw in certain larger categories of pollinators at that higher level taxa. And so there were things like the groups were honeybees, bumblebees, small dark bees, 7 categories of bees were identified, some Lepidoptera, which are butterflies and moths, beetles, flies, and a group of bugs. So that was kind of the generalized groups that she was accounting for. I also want to say, I guess, like, she did that. The reason, like, it's not so important to understand exactly what species of bee or fly or, is visiting the flowers is because she was counting the number of times that these were visited as an indication of how appealing they were or how attractive one flower was as compared to the cultivar or another flower. And so it wasn't she wasn't as concerned about the species of insect. That wasn't the question we were answering. And so it was not necessary. It was just a counting method. So a research summary, 6 of the 11 native species were preferred to the cultivars. Again, here's a little bit of a spoiler alert, which 4 were equally preferred and 1 cultivar was preferred when compared to the straight species. I think that was, for me, that was unexpected. And it is interesting to ponder as to what was going on there. And I have some theories. No results nothing has been determined, but I have some thoughts and I'll share them with you. And if you have thoughts, I would love to hear them too, because I think it's a fascinating outcome. Okay, so let's talk about some of these plants. All right, so yarrow. The cultivar selection was strawberry seduction. And now the straight species of the flower is pictured here. They are white, or with pale yellow centers, kind of depending on the maturity of the flower. Strawberry seduction is derived from repeat selections. So there's a lot of human interaction. This could not occur, or is very unlikely to occur naturally in the wild. And it was a selection from a cultivar of summer pastel. So there was a selection and then there was more selecting done to achieve the cultivar strawberry seduction. And this one is more red colored flowers with a kind of gold center. They're described as being rich velvety red flowers. And so this is a floral color change that occurred. This was why it was selected. It was to change the floral color. The form did not change. The form of the flower was still like that flat topped umbel. And so just the color, the size of the plant didn't change either. It wasn't noted that it changed. And so observational results indicate a strong preference for the straight species. 12-1 preferred the straight species, and twice as many bees preferred the straight species, and twice as many flies preferred the cultivar, which is interesting. And so you will remember I told you to keep that red, that inability to see red flowers in mind with bees. That could be what's happening here. With the floral color changing to red, from a white to a red, it is possible that the bees just never saw those flowers. It made it invisible to them, whereas flies can see red. Potentially some fragrance change. Flies are attracted by fragrance. Not quite sure what's going on there, but like why they would have preferred the cultivar, but kind of an interesting outcome when it comes to a strawberry seduction yarrow as compared to the straight species. And these hyssop. And so the cultivar that they were looking at here was Golden Jubilee. Now, Golden Jubilee, so what you see here is the straight species, kind of those bottle brush, purple flowers, gold, clean green foliage. Golden Jubilee still produces those lavender bottle brush blooms, very similar to the straight species. But it is said to have a lighter colored green foliage than the straight species. So that's where that golden kind of comes in. Like the leaves are more of a golden color, or have more of a golden hue to them. So the observational results indicate that bee species showed no strong preference between the straight species or the cultivar. It said bugs and beetles did exhibit a preference for the straight species. And so what's happening here is hypothesized that when you change the foliage color, that's not what pollinators are primarily attracted to. They're not concerning themselves with whatever color the foliage is. They're seeking the pollen and nectar resources that the flowers offer. So they're looking and being attracted to the flowers. And so by not changing those flower characteristics, potentially they're preserving the preference and the usefulness of Golden Jubilee anise hyssop for pollinators. All right, so butterfly milkweed, that bright orange, that just stunning glow, like I think it glows, orange color of the straight species, as you can see here, was modified in the cultivar to Hello Yellow. Now Hello Yellow has bright yellow blooms, as you might have guessed with the name. And the other plant characteristics with butterfly milkweed have stayed the same. They did not change. It was strictly a floral color change. The form didn't change, bloom time didn't change, size of the plant didn't change, length of the bloom time did not change. So observational results with this indicate that there is no significant preference differential from the straight species over the cultivar by bees or other pollinator groups. So it was in fact, though, that during this study, Hello Yellow received more visits than the straight species, so 3 to 2. So this is interesting because more pollinators visited the cultivar when it was changed from orange to yellow. What does this mean? We don't fully know. As you would, I'm going to keep saying that because we need more research, we need more data. Perhaps potentially this was a fluke, potentially there's something here. It is curious, though, that it went from a dark, kind of intense orange, almost red in some cases, colored flower, and it moved farther away on the color spectrum from red, and it went to yellow. So it's possible that by changing the flower color from orange, which on the color wheel is right next to red, and moving it one step farther away from red, that it potentially became more visible to bees. There was maybe just a brighter calling than the straight species. We don't know. It's something to ponder, and that's why I find this fascinating, because this is something to ponder. There's so much more to learn. So, bee balm. Oh, Monarda. So the cultivar that was tested here was Claire Grace. So this is an example of a cultivar that was selected for reasons not related to the bloom. So the blooms didn't change, but powdery mildew is a huge challenge with the straight species of Monarda. And it can make it undesirable as a landscape plant, even though it is, it can be stunning. That powdery mildew can make it challenging in a landscape setting, in a formal landscape setting. So Claire Grace is a selection that was developed in a little bit farther south in the United States. So it has a little bit more resistance to, powdery mildew and to drought. However, the trade-off, because it was developed in some farther southern locations, is that it is just a little less cold hardy than the straight species that we have available to us. So it's marginally hardy and up to zone 4. So that's all of Illinois, just the northernmost parts of Illinois. When we get a really cold, unusually cold winter, it might be affected by that. And so the study results show no strong preference for the straight species or Claire Grace. There was a slight preference from bumblebees showed at one of the sites. Again, more research needs to be done besides having 2 data points to compare these two. Not sure what was going on there, but because the species was, or the selection was chosen for plant characteristics, so health reasons, without powdery mildew, and then drought tolerance without changing the floral display too much, seems to not have had much of an effect on pollinator preference. Penstemon. Okay, I'm going to go ahead and out myself. This is one of my favorite flowers. And so we have to talk about this. And I was thrilled to see it in the study. So the photo here is of Husker Red. This is a very popular cultivar. What it does is it's a very similar plant to the straight species, except the leaves in the, in the early part of the growing season emerge with deeper red hues in them. So the venation, the leaf color, it's fading here in this picture because this is past even bloom time, but you can see those lingering effects of kind of that red preference that was selected for in Husker Red. And so again, the floral display did not change. The species has a tubular flower. The selection still maintained kind of that tubular shaped flower, same size, same display. So no strong preference here. You can kind of see a pattern here. It seems to be that when we modify plants for either health reasons or foliage changes, and we leave the flowers alone, they don't change too much. It seems to be that it doesn't affect the ability of pollinators to see the plant and utilize the flowers. Then we've got black-eyed Susan. So black-eyed Susan is native to areas with wet soil profiles in the east of the Mississippi. Goldstrom is the cultivar that was selected here. It is a more compact and a more coarse selection. So again, it changed, the plant size changed. It kind of got tightened up. If you've ever planted this, it's not quite so leggy, not quite so open form. It's more of a compact, well-behaving plant. And then it's just a little bit smaller. It does have a shorter bloom time, which is something to consider when we're planting for in service of pollinators. We need to make sure that if we're trying to attract and trying to feed and support pollinators, that we have nectar and pollen available all throughout the growing season. Now, if you were just singularly planting Goldstrom as the source for the summer blooms, Goldstrom has a shorter bloom period than the straight species. I suspect no one's doing that, but it was something to note that it does have a shorter bloom period. And again here, no strong preference. Again, the plant was modified not for the floral characteristics, but for the plant characteristics. Okay, so Ohio spiderwort. So this is red grape. Now, this one's really interesting because in order to get red grape, to go from that really deep blue flower color that is exhibited on the straight species and get it to be kind of that pinkish hue you can see in the top picture, it required the crossing of like 3 different crosses. 3 different species were involved in achieving this. And so highly unlikely to have occurred in nature, especially because the native range of some of the species that were used in this cross barely overlap. Kind of down in Oklahoma, I think, kind of region, there's just that Venn diagram, there's just the teeniest little bit of overlap. So highly unlikely to have occurred in nature. And so it was bred for a compact form and that magenta flowers. And now what is interesting is that there was a strong preference observed between the 2 species. And so they preferred the straight species over the cultivar. And so a very strong preference. Now, sneezeweed. And so sneezeweed's interesting because Moorheim Beauty is the cultivar that the straight species was compared to. Now, Moorheim Beauty is a hybrid produced in a controlled cross between Helenium autumnale, which is our native locally native species, and Helenium biglovii. Good gracious, I always mess that up. That species is native to like the Northwest United States. And when I say controlled cross, these two species never overlap. There's a whole mountain range in between. There's many states, many miles, and a whole mountain range in between the native ranges of these two species. So they would not have hybridized on their own in nature. So this was a controlled hybridization. Now the sneezeweed of the Northwest also blooms during the summer. Ours is more of a fall blooming plant. In the Northwest and the Pacific Coast, the sneezeweed blooms in the summer. And so the bloom times of the two species that were in a controlled cross don't even bloom at the same time either. So as the name, let's see. So as a result of this hybridization, the cultivar is kind of a reddish bronze bloom, and it blooms in the summer. And so the results of this study have little asterisks by them, because when it's compared to the straight species, they didn't overlap in the bloom time. So the cultivar bloomed in the summer and the straight species bloomed in the fall. It makes it hard to compare the data in a meaningful way because there are so many variables that would happen during those seasons. So while the summer blooms were being produced by sneezeweed, it did show a preference for the native species. But is that because in the summer so many more plants are blooming that they were just choosing other summer blooming plants over the cultivar? Maybe it's this perfectly suitable plant, or is perfectly attractive to pollinators. Just in this case, there were other options available. Maybe not. That I'm not saying one way or the other. There's just too many variables, to consider. There's also, did the bloom time, did that affect anything? So, or the bloom, I'm sorry, like the duration of the bloom period, did that affect visitation? Very hard to compare things when we change the bloom season. So in summary, what I'm taking from this research first is that for the most part, straight species are preferred. When we can choose straight species, you're hedging your bets because there was evolution that occurred with them. Some of the research indicates that they're more preferable. If we are going to be choosing cultivars, consider what changes have been made in difference to the straight species. We do need ongoing evaluation. We need to better understand. It's kind of on a species by species level. We don't know what the quality of the nectar or the pollen is for those species for those cultivars that are preferred. Is the quality of nutrients that they're getting from the nectar and pollen, is that comparable to the straight species, or is it comparing apples to candy bars? We don't know yet, and there's research going on that level too. And then cultivars and straight species do offer strengths and challenges. None of these plants had the outcome or the result that nothing visited it. Even cultivars that were not preferred by pollinators did have pollinators visit them. And so what I take away from this is balance, right? If there is a cultivar that you just think is so cool and so unique and you must have it in your landscape, I think it's fair to say that the chances of that being visited by pollinators and supporting pollinator life is going to happen. It might not be at the level that a straight species would, but it's still going to provide some nectar and pollen. So I don't want anybody to feel shamed or feel like you cannot plant your wild and unique cultivars. It's just have this information in the back of your mind as you're making choices and setting those goals for your landscape. So then finally, what do we do? Well, we do plant native plants when we can, where we can, at the tolerance level that we have for them. And then we also plant native cultivars because, like I said, they're still serving an ecological service to pollinators. Make sure you have blooms all season. It is no good to any of the pollinators to run out of food when fall hits and they have done all this work to survive all year long, and then we don't have a fall planting for them. Or we don't have early blooming plants when they're trying to, establish those broods and rear those young and get a new generation going after a hard winter. So have blooms all season long. Do not forget about trees and shrubs. Trees and shrubs are wonderful sources of nectar and pollen for so many of our pollinators, especially in the early parts of the season. Some of the first things to bloom in the year, you can walk by trees like willows and they'll just be literally buzzing. Like they can catch your attention with all of the critters that are feeding on them. So do not forget about trees and shrubs. Adapt cultural practices that support pollinators. We didn't even talk about this, but if you want to plant for pollinators, some of those ground nesting bees need access to the ground. Be a messy gardener. Leave your plant material from last season throughout the winter so they can overwinter in that twig material and that stubble. Leave it extended into the spring so that they have time to emerge. That first warm day in March is not the time to be cleaning out the garden and burning or disposing or composting all of our materials, because those critters might still be hibernating or overwintering in that stubble. So adapt some cultural practices that are going to support pollinators. And finally, I encourage you all and I ask you all to stay curious. I've said a number of times, we have so much more to learn. I think we are on the right track. I'm so proud of our gardeners, of our growers, of our industry for doing what we can to help promote and advance the mission of preserving pollinators. We have a long ways to go and we have so much to learn. So just stay curious. Illinois Extension is here to help you. There's so many good resources. I'll go ahead and put my information up here. 2 wonderful resources available to you all is the Good Growing blog. This is an Illinois Extension blog posted every week on a variety of horticulture topics, a lot of pollinator stuff, a lot of native plant stuff. A couple of the contributors, I'm one of the contributors to the blog. One of them is an entomologist, and the other one is, the other 2 of us really love native plants, trees, shrubs, native ecosystems. So a lot of good information on that blog. And then we have a new website through Illinois Extension. It's the Illinois Pollinators website. This website is first beautiful, but more importantly, super functional. You can select for certain colors of flowers or certain insects or certain objectives, and it's very interactive and a wonderful resource. So I encourage you all, I'll leave that up there for a few minutes, but I encourage you all to visit those websites and subscribe to the blog. Like I said, it's every week. So I thank you. I'm not sure if Holly got her mute challenge worked out, but I see there's a question. Are you there?
I am. I had to get on my phone because I couldn't get my computer volume to work, but I have been listening to the whole conversation, the whole PowerPoint, and this has been wonderful. I do think that there was one chat that came in. I'm sorry. There was one chat that came in, and but we'll open it up to any other people that have any other questions that would like to join in the conversation.
Yeah, I see the question here. I'll read it so everyone knows it. So it says, is there any research to indicate that as cultivars are created for hardiness to counter global warming, that there will be a trade-off with plant pollinator attraction? That is a fascinating question. I am not aware of it, and that is not to say that it is not happening. I don't know. That's a fascinating question. Yeah, I don't know. I'm going to have to do some research now too. If you shoot me an email with that, I can see what I can find and we can communicate as I dive into that a little bit more. We do have, Dwayne Friend is our, Holly, help me out. I always mess up he's our climate.
He joined us last week and talked about tornado. Is Illinois in the new tornado alley? And he was extremely interesting last week when he joined us.
Yes, he is wonderful. He is fantastic. I'm so glad you got to hear from him. He might also have some insight as to how, the changing climate, because it's not just global warming, right? We're having different climate, you heard all this from Dwayne. We're just having different precipitation patterns occurring. We're having different highs and low temperatures. We're having different nighttime temperatures. These things affect plants in really interesting and unique ways. And it is possible that it could affect pollinators. I'm thinking of things now, plants that are, that when the temperature gets too high, they're going to preserve themselves by becoming sterile. So that's a self-preservation strategy that some plants have adapted. If we have more, higher temperatures, it's possible that the quality of the nectar, the availability, nectar and pollen is altered. Plants do replenish their, I guess one thing we didn't talk about briefly. So along with like being able to reach nectar, the nectar needs to be in a form that can actually be like lapped up and consumed by pollinators. And if it is too concentrated, it can become too thick for insects to consume. And so, that is affected by temperature. Warmer temperatures make it a little bit more liquid versus colder temperatures. And so I don't know. There's so many unknown. I've got so many questions now.
That's what's fun about these weekly things is we get the coolest questions.
Yeah, you guys are brilliant. It says, okay, so what can I grow creekside that beavers will not eat? Ooh, non-woody plants. Beavers are, they are not very picky when it comes to harvesting woody plant materials. Yes, I'm sorry, that's not what you wanted to hear. I know that. I have some property and some beavers have done some damage. You can protect them just with a little bit of, you can protect woody plant materials with some exclusionary measures. So I'm thinking of like some wire fence or wire wrap around them. And I don't think it needs to be much. My experience is that beavers aren't too interested in removing those barriers. They just move on. So some of your prized trees or your young trees, you would want to maybe just fence off. Make sure that that's not touching the trees. You want to, that can cause some damage, not from the beavers, but from the interaction between metal and trees. But yes, they're a formidable opponent. Any idea if when the color of the flower bloom has been changed from the original straight color, the cultivar color, if the fragrance of the flower or taste of the nectar or pollen changes? So this is also an interesting question. I think it's going to be species dependent. And I do not know that research is going on so heavily on the fragrance of the flower, unfortunately, because bees are the primary focus of a lot of this research and a lot of the, because they're the primary pollinator. Moths are the primary fragrance they're the primary pollinator that is attracted by fragrance. I do know that some breeding programs and some changes to plants can affect fragrance, and you will all probably know exactly, like have experienced the exact results of these breeding programs with a bouquet of roses. So in order to get the longer, more robust cut flower roses that we all adore at the floral shop, through those selections and breeding programs, the fragrance genetics were tied to it and we're actually lost. That's why our roses that are long stem roses, red roses, yellow roses, don't have that fragrance of like tea roses. Because those two genetics were linked together. So it's possible. It is possible that the manipulations that we're doing could affect the fragrance. Other than monarchs, do we have any info on threatened pollinator species and native plants we might grow to help them? Yeah, all of them. Like anything we can do to help. So bees are a primary pollinator, and especially the solitary bees, they are, they're those ones that have to work really, really hard, and they ground nest. And so oftentimes we're tidying up, we're putting down, lots of mulch on our gardens. We're not leaving bare patches of dirt, undisturbed bare patches of dirt. Either we're cultivating it every season and tilling up, the soil to, get all the weed seeds, germinated so we can take care of them and get them out of the landscape. Or we mulch over everything to suppress those weed seeds, but then that soil is inaccessible. And so, that's one thing you could do to help pollinator species is just leave some bare soil. It doesn't have to be in the front of your garden either. It can be in the back. They'll find it. You can provide like snags or kind of like nesting areas for these for insects or protective areas. So if you're planting trees, consider native trees, especially ones that have like exfoliating bark. I'm thinking of like river birch or shagbark hickory. Those provide protective areas for butterflies and moths and other insects. Kind of like think of their whole life cycle. And so we can plant certainly for food. Anything's going to help. Most of our pollinators are generalists. They'll visit a variety of flowers that are available if they can see them. But then there's other aspects of the life cycle that also do need to be considered. Also, a reduction or a very conscious use of chemicals in our landscape can go a long ways to help threaten pollinator species. Oh, I guess I'll also say talking to people. I have an entire native landscape in my house, and people come over and they ask all the time, what is that? Why is that there? What, and it's an opportunity to share what I know and give some seedlings away because some of them go to seed or just, kind of share our love of helping pollinators.